Hi guys, this is AS Chemistry, Organic Chemistry, and we are doing alcohols. Question 1. Compound J can be produced from 2-chloro-3-methyl butane. Give the reagents and conditions for this reaction. So, compound J is a secondary alcohol. So, when it is produced from 2-chloro-3-methyl butane, the chlorine atom is substituted by the OH group. So for this, we would need the presence of NaOH. And since we are forming an alcohol, we will not add an alcohol along with NaOH. All we will do is we will heat the reactants under reflux. So NaOH aqueous and heat under reflux, and this will convert 2-chloro-3-methyl butane into compound J. Question 2. The alcohols C and D are isomers of each other with molecular formula C4H10O. Both isomers are branched. When C is heated under reflux with acidified potassium dichromate, no color change is observed. So it means that C is a tertiary alcohol. When D is heated under reflux with acid potassium dichromate 6, the color of the mixture changes from orange to green and E is produced. And since E contains two oxygen atoms, it means E is a carboxylic acid, which means D has to be a primary alcohol. E reacts with aqueous sodium carbonate to form carbon dioxide gas. So this confirms that E is a carboxylic acid. Identify C, D, and E. So C has to be a tertiary alcohol. So in order for the alcohol to be tertiary, we need the OH group to be present on a carbon atom to which there are three R groups attached or alkyl groups attached. And since we've got a total of four carbon atoms, so each of the three R groups would be a CH3 group. So this is the tertiary alcohol C. As for D, it has to be branched and it has to be a primary alcohol. So in order to turn this into a branched primary alcohol, so we will place a CH3 group next to a CH group to which we will attach another CH3 in order to introduce branching. And since it has to be a primary alcohol, then we have a CH2 and then an OH group turning compound D into a branched primary alcohol. And as for E, this is the oxidation product of compound D, which is a primary alcohol. So this has to be a carboxylic acid. So we will draw the same structure as D, which will begin with CH3 attached to CH, to which another CH3 group is attached to. And then the CH2OH group is converted into the COOH group for the carboxylic acid. And in order to name these compounds, we will use the IUPAC nomenclature. So compound C will be called 2-methyl propane 2 all. Compound D would be called 1, 2, and 3. So this would be called 2-methyl propane 1 all. And compound E would be called 2-methyl propanoic acid. Write the equation for the reaction between E and aqueous sodium carbonate. So E would be written as CH3 twice CH COOH plus Na2CO3. So we would need 2 moles of the acid to react with 2 moles of sodium ions that are present in sodium carbonate, and this would form 2 moles of the sodium salt of the carboxylic acid. So CH3 twice CH COO minus Na plus, and then we have liberation of carbon dioxide gas and production of water. Question 3. The compound trans 4-hydroxy 2-nonenal or HNE for short is thought to lead to infections of the lung when cigarettes are smoked. Its skeletal formula and condensed structural formula have been shown. Give the structural formula of all of the carbon containing compounds formed in each case when HNE is reacted separately with the following reagents. And here we have it reacting with hot phosphorus trichloride. So when it reacts with hot phosphorus trichloride, the OH group present is substituted by the Cl atom. So we will have the exact same structure as trans 4-hydroxy 2-nonenal, and instead of 4-hydroxy, it will become 4-chloro. So using the condensed structural formula, we will write CH3, CH2, 4, then we will have CH, in the brackets we will have Cl, then we will have CH double bonded to another CH to which a CHO group is attached. And this is the product upon reaction of the given compound with hot phosphorus trichloride. Question 4. 2-ethyl 3-methyl butanoic acid is given. A sample of 2-ethyl 3-methyl butanoic acid may be prepared in a school or college lab by the oxidation of 2-ethyl 3-methyl butane 1-ol. So if it is butane 1-ol, that means it is a primary alcohol, and that is why it can be oxidized to a carboxylic acid. State the reagents that would be used for this oxidation and describe what color change would be seen. So we can use acidified KMNO4, or we can use acidified K2Cr2O7. So color changes in the case of KMNO4 would be purple to colorless, and in the case of acidified K2Cr2O7, the color change would be from orange to green. This reaction is carried out by heating the reacting chemicals together. What could be the main organic impurity present in the sample of the acid? Explain your answer. So, since it is a primary alcohol, it is not directly oxidized to a carboxylic acid. Instead, a primary alcohol is oxidized first to an aldehyde, and then the aldehyde is oxidized to a carboxylic acid. So, the impurity that might be present would be the aldehyde if it has not been completely oxidized to the carboxylic acid at the point when we are looking at the product we already have obtained. So explain your answer. A primary alcohol is first oxidized to an aldehyde, and then the aldehyde is oxidized to a carboxylic acid. The main impurity present would be the remaining unoxidized aldehyde. State whether a distillation apparatus or a reflux apparatus should be used. So we need to completely oxidize all of the primary alcohol and the aldehyde into the carboxylic acid. So if we use a distillation apparatus, then we are removing portions of the uh, organic products at a given temperature. So that is not what is required. What is required is complete conversion into the carboxylic acid. So we will use a reflux apparatus. A reflux apparatus is needed to carry out complete oxidation of the organic contents into the carboxylic acid. And since a reflux apparatus will not allow anything to escape during the reaction, everything present in our container would eventually be converted into the carboxylic acid. A structural isomer of 2-ethyl 3-methyl-butane-1-ol is 2-ethyl 3-methyl-butane-2-ol, and its condensed structural formula is given. What color change would be seen if this were heated with the reagents you have given in B1? Explain your answer as clearly as you can. So, if we look at the structure of this alcohol, so we've got two CH3 groups attached to a CH group, to which we have a carbon atom attached, which is attached to an OH group on one side, a CH3 group on one side, and a CH2 CH3 group on its remaining side. So, if we look at this carbon atom, it has a CH3 alkyl group, a CH3 CH2 alkyl group, and a CH and with two CH3 alkyl groups. So, it has got three R groups present. So, that makes this a tertiary alcohol. And since tertiary alcohols do not undergo oxidation, there would be no visible change observed. So we will write no visible change observed as the given compound is a tertiary alcohol which does not undergo oxidation. Question 5. The structural formulae of six different compounds P to U are given below. Compound S can be converted into compound R. What type of a reaction is this? So looking at compound S, we've got 1, 2, 3, 4, 5. It's pentane 1-ol. So it is a primary alcohol and it is converted into R, which has a double bond present between the first and the second carbon atom. So this is a dehydration reaction. So we will write dehydration, and dehydration is an example of an elimination reaction because H2O is eliminated from the molecule. What reagent would you use for this reaction? So dehydration has two possibilities of reagents and conditions used. We would use either Al2O3 at 350 degrees Celsius, or we would be using concentrated H2SO4 at 170 to 180 degrees Celsius. Write the structural formula of the compound formed when T undergoes the same reaction using an excess of the reagent you have used in C2. So if T undergoes the same reaction, so T has two OH groups present. One is present on the terminal carbon and the other is present on a central carbon. So two water molecules will be eliminated and we would end up with CH2 forming a double bond with a CH group, which forms a single bond with another CH group, from which the second OH would have been lost, which forms a double bond with another CH2 group. So in this way, we have introduction of two double bonds in our compound because two molecules of water were eliminated due to dehydration. Compound P may be converted into compound Q in a two-step reaction. So compound P has a double bond and compound Q has a ketone group present. So that means compound P would be converted into a secondary alcohol in order for the secondary alcohol to be oxidized to compound Q, which is a ketone. So what is the structural formula of the intermediate compound formed in this sequence? So the C double bond O group is the third carbon atom in compound Q, which means the OH group will be added to the third carbon atom in compound P. So the structure of the intermediate would be CH3, then we would have CH2, then we would have CHOH. This is the third carbon atom. Then we would have CH2, and then we would have CH3. So this is the structure of the intermediate produced in step 1. Outline how step 1 may be carried out to give the intermediate compound. So step 1 is basically hydration of an alkene. So hydration of an alkene is the reaction of this alkene with steam, which is H2O gas, in the presence of H3PO4 and SiO2 at a temperature of 300 degrees Celsius and a pressure of 70 atmospheres. So hydration of the alkene occurs, resulting in the formation of a secondary alcohol. What reagent would you use for step 2? Step 2 is oxidation, and the reagents that can be used are either acidified KMNO4, in which the color change would be from purple to colorless, or we can use acidified K2CR2O7, where the color change observed would be orange to green. Question 6. Crotyl alcohol is a colorless liquid which is used as a solvent. In the boxes below, write the structural formula of the organic compound formed when crotyl alcohol is reacted separately with each reagent under suitable conditions. If you think no reaction occurs, write no reaction in the box. So the first reaction is with Br2 in an inert organic solvent. So Br2 will be uh, adding onto the two carbon atoms having a double bond between them. So this is electrophilic addition. So the product of this reaction would be CH3, CHBr, again CHBr, because these are the two carbon atoms, the double bond between them. Then we would have CH2 and finally OH. So this is the product when crotyl alcohol reacts with bromine in an inert organic solvent. Next, we have reaction with PCl5, and PCl5 reacts with the uh, alcohol portion of the crotyl alcohol, and the OH undergoes nucleophilic substitution and is replaced by a chlorine atom. So the product would be CH3 CH double bonded to another CH because nothing happens to the double bond, and then we would have CH2 and then finally Cl. In the third reaction, we have hydrogen and nickel catalyst. So this is hydrogenation, and this will result in hydrogen atoms being added to the double bond. breaking the pi bond and adding two hydrogen atoms, one on each of the carbon atom that had a double bond between them. So this would result in the formation of a compound which will have CH3, CH2, 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 and then OH with NaBH4. NaBH4 is a mild reducing agent. We don't have any groups present in crotyl alcohol that will undergo reduction. So no reaction would occur when NaBH4 is added to crotyl alcohol. And finally, we have acidified K2Cr2O7 and heat under reflux. So nothing would happen to the double bond because double bond does not react with a mild oxidizing agent. However, the alcohol group present is a primary alcohol, CH2OH, which will be oxidized to an aldehyde, and the aldehyde would finally be oxidized to a carboxylic acid. So in our crotyl alcohol molecule, the CH2OH portion would be converted into COOH. So the product would be CH3, CH double bonded to CH, and then single bonded to COOH. Question 7. Compound Q, heptane 2-one, is found in some blue cheeses. Compound Q may be reduced to R. So if it is a ketone, it will be reduced to a secondary alcohol. Compound R may be dehydrated to give two different products, S and T. So since the double bond would be present on the second carbon atom or the first carbon atom, we can have two different alkenes produced. And the reason the double bond can be present on the second or the first carbon atom is because the OH group is present on the second carbon atom. So when dehydration occurs, the hydrogen may be lost from the first carbon atom or the third carbon atom. If hydrogen is lost from the first carbon atom, then the double bond will be present between the first and the second carbon atom. And if hydrogen is lost from the third carbon atom, then the double bond would be present between the second and the third carbon atom. So they've asked us to draw the structural formulae of R, S, and T. So when compound Q is reduced, it is converted into CH3, then we have CH2 four times, and then CO becomes CH, OH, and then we have CH3. So this is the secondary alcohol that is formed from the reduction of compound Q. And now, when R undergoes dehydration, we can have the double bond present between the first and the second carbon atom or the second and the third carbon atom. So in compound S, let's make the double bond be present between the first and the second carbon atom. So this will give us a product which will have CH3, then we will have CH2 four times, followed by a CH double bonded to a CH2 group. And in compound T, we will place the double bond between the second and the third carbon atom. So we will have a CH3 group followed by three CH2 groups because we need the fourth CH2 group to remove the hydrogen, forming a CH group double bonded to another CH group, which is bonded to a CH3 group at the other end. So these are the two different alkenes that are produced when compound R, which is a secondary alcohol, undergoes dehydration. State the reagents that would be used for each of these reactions in a school or college lab. So reduction. When reduction occurs, a ketone is converted into a secondary alcohol. So there are two possibilities for the reagents used, which can either be LiAlH4 plus dry ether. These are harsh reducing conditions, or we can have NaBH4 plus water, which are milder reducing conditions, but ketones can undergo dehydration under both of these conditions. And as for dehydration, also there are two possible conditions that can be used. Either we can have Al2O3 at 350 degrees Celsius, or we can have the use of concentrated H2SO4 at 170 to 180 degrees Celsius. Both of these conditions can carry out dehydration of a secondary alcohol to form either of the two alkenes which are represented by structures S and T.